Imagine we are sitting comfortably, just two friends having a conversation about a fascinating concept in Python that helps us find pairs of numbers that add up to a certain value. This discussion is all about the pair sum problem. It's not just about solving the problem but fully understanding why and how Python can tackle it in various ways. So let's dive in. Picture a game where you are given an array filled with integers, sort of like the numbers in a hand of playing cards, and a target sum, which is like a magic number we are trying to achieve by picking exact pairs from our hand of cards. The problem is to figure out if there's a pair of these numbers that, when added together, give us the magic number. And hey, this isn't just any programming challenge, it's a popular topic for beginners diving into Python, especially when they're getting their feet wet with lists, loops, and conditionals. Now, let's first look at a straightforward Python solution. It's simple yet effective. We'll just sift through each number, compare it with every other number in the array, and if the sum matches our target, bingo. But this baby is not the quickest, so it's not what we're here for. The main idea here is the process. We are iterating through each element of the array just once, using a nested loop to go through the list again, checking for pairs that sum up to our target. Here's that in code: Python definite find underscore pairs underscore brute underscore force, for I in range for j in range if numbers plus numbers is equal to target underscore sum, print. But hey, even Python savvy folks out there know that sometimes there's always a faster way, and this is where we start playing with our array differently. This next method is way cooler. It brings in a dictionary or a hash map, a concept that Python natives love. Here's how you do it. As you iterate through the array, add each number to the dictionary, but here's the catch: keep storing the index of each number too. And for every number we go through, we subtract it from our target sum and check if this resultant is already a key in our dictionary. And if we've found it, there it is, the pair. This way, we are significantly cutting down our search time, especially for larger arrays. Let me show you that approach in Python. Python definite find underscore pairs underscore efficient, number underscore map is equal to, for index, number in enumerate, potential underscore match is equal to target underscore sum, number if potential underscore match in number underscore map, print number underscore map is equal to index. And the magic doesn't stop there, my friend. Python allows for even more magic using sets and lists, which not only find unique pairs, but also ensure they're not repeating. Imagine putting our numbers into one set and flipping the script by using another set containing our target sum minus every single number. This way, when we iterate over each number, we only need to check if our difference between target and current number is in that second set. Then we are left with only once looping through the array. Cool, eh? But wait, there's one more trick up our sleeve: Python's list comprehensions and sets. This will reduce an extra sorting step, making this slick and quicker. So, let me write that one up for us. Python definite find underscore pairs underscore no underscore repeat, numbers underscore set is equal to set potential underscore mates is equal to set pairs is equal to unique underscore pairs is equal to for pair in pairs, if pair is equal to pair, unique underscore pairs dot append for pair in unique underscore pairs, print. Now, as much as I love Python, I'm aware of two other languages that make excellent pairs, C and C++, and these languages take it up a notch. They handle the same problem using sorting, something we didn't discuss yet, but let's cover it quick. They sort the array and set pointers to point at the start and end elements, looping until they meet in the middle. This way, if their sum matches the target, boom, found pair. Now this approach is a breeze compared to our previous ones and performs exceedingly well for larger lists. But remember, there's always a twist in the world, and in this case, this nailed method doubles up backtrack with extra array allocation, a sneaky trade-off situation. Moving on from arrays and into more advanced territory, we enter sorting algorithms and divide and conquer strategies. We sort the array and run binary search to find pairs summing to the target on each element. While it may sound complex, understanding the concepts of merge sort and quicksort becomes essential in grasping why sorting is often an efficient solution. Along come algorithms like Van de Boas trees and the two-sum problem. These algorithms have various approaches, like prioritizing indices with values close to the target and using priority queues or special tree structures to enhance efficiency. Although, keep in mind, some of these algorithms lean towards specific scenarios due to memory requirements or complexity considerations. We don't shy away from discussing the worst-case scenarios, can get pretty taxing, and when dealing with huge lists, that's where we might hit an impasse. In these situations, it is the realm of data-structured libraries, like NumPy and Pandas, offering a beacon of hope. They allow us to employ more SOF0M3 data manipulation techniques and apply broadcasting and apply methods, significantly speeding up our pair sum hunts. We are no longer bound by plain arrays, but empowered with more sophisticated tools. Of course, we can't gloss over optimization techniques. The clever use of extra space, early termination, and two-pointer techniques provide additional buffers against hefty performance hits. Even though our pair sum problem might seem simple, it hides intriguing puzzles and challenges that push your problem-solving capabilities. And finally, as we round up our delightful conversation about the pair sum problem, let's not forget about online learning and tutorials that make this whole experience more intuitive. Platforms like Codecademy and Coursera, along with interactive websites, enrich our journey towards understanding Python and algorithms like pair sum with their engaging lessons, quizzes, and hands-on coding exercises. Pair sums, from a simple pair-finding algorithm to an intersection of optimization strategies, data structures, and real-world applications, truly captivates our computational curiosity. They teach us the essence of efficient computing, how to find the essence quickly and accurately, and how to navigate the mazes of algorithmic problems with Python, bringing us to the finish line of comprehension and mastery over the pair sum challenge. Now, remember, whenever you feel like diving deeper, exploring resources, or brushing up on your Python skills, hop on to neeraj.qzzo.io and subscribe to TechLab, where the next piece of our Python puzzle adventure awaits. Visit there, soar high, and keep the coding spirit alive.